Welcome. We are today going to talk about lake ice out in Minnesota and in Minnesota lakes, and it's a subject that really interests me for several years now, and there are lots of reasons of why, and I can talk about that in just a little bit. I first, before we really get going here, is I'd like to say some thank yous. We've been working on this off and on through this last year, trying to bring you better forecasts of ice out on lakes. And this has been a curveball kind of year. But anyway, the Jane Reed of our comms unit at Minnesota Sea Grant, and John Emmer, who's a student at UMD, who's helped a lot with the modeling and pulling in thousands of lines of data on lake ice out, and Marie Toms for letting Jane help me and also giving me input on how what people might be interested in with respect to lake ice out. So I'd like to thank them. Without them, this tool would not have been created. And some of you may have already seen we had a widget last year that would give you some guidance. It was a little mysterious in how to run it. We've tried to make it smoother and more beautiful this year, and I hope it's useful to you. I just wanted to say thank you to those great people who've been helping me out with this near obsession with ice out in Minnesota. And I'd also like to thank others, Hillary Sorensen of Minnesota Sea Grant, who's going to be actually running the Q&A today, and Jan Sandberg and Carrie Bates of Itasca Waters, one of our great partners that we work with in Minnesota Sea Grant. And Hillary and I work with the Itasca Waters group in the Practical Water Wisdom series. And if you haven't run into that, please go to itascawaters.org and see the really cool presentations that come out on the web about once a month, and are actually completely run by the Itasca Waters Board of Directors and the Education Committee. So you don't see them on the screen too much, although I put Hillary up on the screen. But they volunteered to help in background with Q&A. And concerning questions and answers, please feel free to put questions into the Q&A section anytime. We're not using the chat function, but we'll use the Q&A, and then Hillary and Jan and Carrie will feed me some questions, and I'll try to the best of my ability to answer them. Please put those questions in anytime as you think of them, because, well, that's what I do, because if I wait too long, some other topic comes up and I forget the question. So please, give us, put in your questions as soon as you feel like it, and then we'll get around to answering them. And before I talk about ice, I should talk about Sea Grant. Some of you may not have heard about Sea Grant or know what Sea Grant does. We are part of a network of programs across the United States and out into the oceans who serve the local people who need water science, and we provide accessible research data to industry leaders, policymakers, educators, community organizations, municipal governments, university stakeholders, citizens of all ages, and essentially anybody. We serve everyone. And if the science doesn't exist, we fund it to ensure that it gets to those people who need that science, and then bring it to them in a way that it can be used. So water science is what we do. We're funded by the National Oceanic and Atmospheric Administration and the University of Minnesota. We are a system-wide program with a main office in Duluth and another office in St. Paul, on the St. Paul campus of the University of Minnesota. We do a lot of things other than fiddle around with ice. We have 4 or 5 different focal areas. We work to sustain healthy coastal ecosystems. And I often say Minnesota has 180 miles of Lake Superior coast, but we have 32,000 miles of inland waters coast. And we can talk about that anytime you'd like. We work on sustainable fisheries and aquaculture. We try to keep coastal and water-oriented communities and economies resilient to changing environments and challenges that water can bring. We also have a strong program in environmental literacy and workforce development. And because we are the largest port by volume in Duluth, in the Great Lakes system, we have a special orientation toward Great Lakes transport and also the transport of hazardous materials in and around, across and around the Great Lakes. We, as I said, we're system wide. We have offices in Duluth and St. Paul. So that's Sea Grant. Okay, so what am I going to do today? We're going to talk about Minnesota Lakes Ice Out in 2024, and I'm going to introduce you to the new Ice Out clock if you haven't already seen it. And there's a QR code up on the screen, and I'd invite you to capture that with your phone and have a look at it, and we can talk through it, and I'll answer any questions about it you'd like as we go along. And so my first thing I want to say is what just happened. I'm a scientist who usually analyzes and forecasts within the range of data. We are in uncharted territory in Minnesota right now with respect to ice. And you may have noticed that if you've actually been outdoors. It's a remarkable thing. We've had less cold and more early warming than nearly any year in history this winter. And that means we have had thin, warm ice. Now, you may not think of ice as warm, but ice also can have a diversity of temperatures and carry greater or lesser heat deficits, right? So you can have super cold ice, or you can have just frozen ice. Anyway, and we've had more early warming in some places, particularly in the south part of the state, than we've seen than we usually see. We had almost no snow, and that's a serious deal. And had you been able to hear my cracking ice audio, you could have heard the amazing array of sounds that it makes when the sun hits it as it expands. It can actually, a lake that's a mile across can expand by about 50 feet as it warms, even a small degree. And of course, that energy has to go somewhere, and sometimes it slides it up onto the shore, and sometimes it gets stuck and just breaks up and cracks. So our new ice out clock has been forecasting early ice out across the state since the first forecast on Valentine's Day, which I don't know why we chose Valentine's Day. It's just that if you do it really early on, you haven't had any thaw, and a couple of factors that are really important are the amount of thawing weather and the amount of freezing weather. And so freezing weather will predict a bit of it or forecast a bit, but thaw is really important. Now, there are lots of reasons I care about this, and I think lots of reasons you probably are here. That ice out is sort of the yin and the yang of water sports in Minnesota. It's the wall between our winter lake sports like, ice fishing, skating, snowmobiling, skiing. Think how little of that went on this year. I saw so few ice anglers out and so little equipment on the ice. It was amazing. And people who would even drive an ATV across the ice would do so with great care. But anyway, this is the wall between our winter lake sports and summer lake sports like boating, kayaking, canoeing, fishing, water skiing, swimming, diving, you name it. Both of these areas are incredibly important to Minnesotans and are also really economically important to Minnesotans. And if you think of the businesses that serve these various sports that happen or activities that happen in and around lakes in winter and in summer, it would be good if they could know how long the season actually might be. Warmer winters and early ice out also means that warmer summer water with a long growing season might be more hospitable to invasive or warm water species and could give us more plant and algae growth. And some of you, we may start noticing that this year as the ice goes out pretty pretty quickly. If you'd like to look up the ice out clock, and I'll give you links to these later, and the link will come out on the thank you note that we send out after the webinar. But you can go to this QR code, or you can go to the little pretty easy little code at the bottom and pull it up on your computer or smartphone. Okay, so that's my yin and yang. Okay, so what's happening with ice out being later or earlier is that the difference between, well, is that we're stretching or compressing the open water season. And that's how I look, kind of how I first started looking at this. I'm really keen to put first the canoe and then the other boats in the water. And so I wanted to know when I might be able to do that. But as we stretch, the difference between early and late ice out is now about 7 weeks and maybe even 8 weeks this year, which is about 50% the size of the entire summer season, which makes a big difference. The boating industry is worth $1 billion in boat sales annually in the U.S. and supports 11,000 jobs and 690 marine businesses. In fact, this may be a Minnesota number. I'll have to look that up. There's a link on the bottom from the Star Tribune. You can look up the data yourself. Also, the hospitality industry, resorts, motels, camping, restaurants, rental homes, you name it, knowing that you can add or subtract several weeks from your overall business season is really important. Law enforcement and planning. Who looks after traffic? Who does the marine patrols? When do you do the marine patrols versus winter safety? Can the cabins and cottages, can we open them earlier? Can we close them later? Things are changing, and sporting goods, camping gear, bait stores, etc., all need to be able to react to the variability of our highly variable weather. It also, of course, as I said a minute ago, shrinks or expands the ice recreation season, which is also an important part of Minnesota life. If you think, I'm a limnologist and ecologist, and if I think about what happens if you have short ice versus long ice in a season, it also has some limnological or ecological impacts. Let's just talk about short ice, and we can leave the other column as kind of the yang of the yin. The warmer spring, the short ice will give us warmer spring and summer water. My colleague Bob Sterner has done calculations even on Lake Superior and says that a 2-degree difference in water temperature in open water and in late winter and spring means there's going to be a 10-degree difference in water temperature in summer on average. It also is going to lead us, if we have short ice, it'll lead to stronger and deeper stratification. And that means that the thermocline is going to be pretty deep. And those of you who are anglers know that if you're looking for the right temperature for fishing, that thermocline and the thermocline depth makes a big difference. Another concern is oxygen demand. If light cannot penetrate down to the deep water, then you just don't have a lot of reoxygenation of the deep water in the summertime. And also there's going to be less ice scour and bottom freezing. I don't know about where you are, but my grandsons and I were drilling holes in the ice, looking at ice thicknesses here. And we found in some places 6 to 8 inches, and I think we got just about a maximum of about 12 inches of ice thickness. Kind of pretty ice, but because it froze during that cold snap, but pretty thin, and some clearing out of material happens when you freeze the shallows down to the bottom. We're also probably going to see more and different weed and algae growth, and we eventually, if we continue to have short ice, winter ice, then we'll perhaps see a loss of some cool water species, or at least giving them a little difficulty in finding a place where there's oxygen and the proper temperature for life. I'm also concerned about the spread and vigor of aquatic invasive species, biological changes and phenological changes, and chemical changes. Ice freezes out alkalinity. And if you don't freeze it out, then it stays in the water and you can have different concentrations of chemicals. So just a couple of things, because I'm a scientist, I got to talk about those. Okay, so they're, I hope, of interest to you. Winter and spring conditions vary really a lot. Here we have images from exactly the same place. On the 12th of March last year, like 4 days from now, and today, this morning. And you can see that the ice conditions are the ice and winter conditions are extremely different between these 2 years. Here's another picture from this morning. This is, I think in the north central Minnesota lakes, we're beginning to see some weakening of the ice at the edge. You see this is called a shore lead, where you have a wet place. This one is actually refrozen overnight, shore lead, and then cracking, compression cracks, and so on across that begin to weaken the ice. We're beginning to see that. So we should talk about what ice out is. And ice out is pretty easy to figure out when that happens, because all of a sudden there are waves on the shore instead of a lot of ice. And we might talk about why the ice clears out so fast. And I don't know if any of you have noticed this, but you don't have big ice flows floating around after the ice breaks up. But first, I'm going to show you a little video that I did a couple of years ago, recording. It's a time lapse. It'll only take 48 seconds, but you get to see 31 days. You can watch the process, and I'll try to give you a little sense of how it all works. Okay, so here we go. We've got snow. This is 2021 on about the 20th of March. The snow is disappearing. You see the flashing of the sun. Everything is sped up. Some cracking, a shore lead with water along the edge, and that happens from water running in. Sometimes rain will do the same sort of thing, and also moving of that ice sheet back and forth. You can see there's considerable motion on the broken ice. It refreezes, goes through a series of sort of ratcheting effects as the ice begins to break, and then everything goes and it's gone. And one of the reasons that everything goes all in a sudden, and if you'd like to talk more about that, I'd be glad to, is that the lakes are actually warmer at the bottom than they are at the top in the winter. I'm going to just move to the next slide so we don't watch that again. And all that water, which is down at the bottom, is at about 40 degrees Fahrenheit. And so it comes up when the lake mixes, when the ice cover is lost, and will actually it'll melt the ice, the residual ice, really quickly. So that's why it clears out quickly. So let's concentrate on the north central lakes. Many of you may be from that area and may be interested in those lakes. And besides, many of the lakes in the southern half of the state are pretty much ice-free already. A lot of them are, and that's moving up the state pretty quickly. But let's look at those ice out dates for the areas around Hibbing, Brainerd, and Park Rapids, sort of around there. And this is based on several thousand observations of ice out. This is the ice out date in a whole bunch of lakes in the northern half of the state. And you can see that normally ice out for these lakes in that region is sort of the middle of the distribution. This is a big old histogram. Middle of it is right around the 20th of April. Last year was late, and in 2023, the median day or the middle day in ice out was 125 or May 4th. So it has varied really a lot and covers a very substantial range that ranges from late March through the middle of May. Now I got to talk about some variables, and everybody complains when I talk about freezing degree days, FDD, or thawing degree days, so I decided to call them Fred and Ted. So FDD is freezing degree days, and it measures the time and intensity of freezing. And you can see Fred there at the top. And thawing degree days measures the time and intensity of thawing, and there you see Ted at the bottom. Now, a couple examples of freezing degree days, just or Fred, is that 100 Fred units would be generated by 10 days at 22 degrees. That is 10 days at 10 degrees below freezing, right? So that is how we get cumulative cold. Thawing degree days measures the time and intensity of thawing weather. And so the other example is 100 TEDs is 10 days at 42 degrees, or let's say 10 degrees above freezing, or it could happen with 5 days at 52 degrees as well. So the more of those, though the cumulative, um, uh, the the cumulative heat and the more cumulative cold you have, the more ice you have, and the thicker the ice and the colder the ice. The more cumulative thawing degree days or TDDs, then the quicker you're going to melt away that ice. And so those are two pretty important variables. And just to illustrate why both temperature and time are important in melting ice, on the left you see ice at 10 minutes, and on the right you see ice at 1 hour. So the amount of time ice has at a warm temperature matters really a lot, and that will tend to melt it out. Now, I'm going to show you a great big distribution. This is kind of sciencey, but bear with me and I'll try and walk you through it. I'm going to show you well, I'll just show it to you. Why tell you about it? Okay, here's how much thawing does it normally take to melt a lake in Minnesota? And that tends to be, I mean, the quick answer is the most common and middle amount of thawing degree days is about 260. And last year when we talked about this, I said, just watch until you get to the low 200s and your lake should be getting pretty close to breaking up. And you can see those data also on the ice out clock. So the TDD and FDD, you can see how much freezing there is and how much thawing there is every day you look at it. This is for 14,000 lake years of Minnesota data, and thanks to Jane Reed and John Emmer, we were able to pull those together. What you see normally in Minnesota, only 2 or 3% of the lakes have thawed when they have 135 of those units. But now this year, we are seeing ice out in southern Minnesota lakes by about 130 units. It's kind of remarkable. It's a real difference. And 130 is like way down to the left-hand side of this distribution of the amount of heating there has been, the amount of heating it has taken to melt out lakes. So we're really, as I said earlier, in somewhat uncharted territory. But let's think about why that might be. Oh, yeah, I guess before that, you probably want to know which have been early and late years. Actually, 2023, although it really felt late to me and to many people around me, wasn't all that late. It doesn't even really crack a record. Some other sort of late years for ice out are shown on the right-hand column, and then some early years are on the shown in the left-hand column. And we got a lake breaking up on the right there. So lots of things cause lake ice to melt faster or slower. We have thaw degree days. We have freezing degree days. Freezing degree days come first and actually can help a little bit in forecasts in the early winter of when the lakes are going to break up. So the size of lakes is also important, and bigger lakes tend to break up more slowly. And in fact, for every power of 10 difference in the acreage of a lake, you can add a couple of days to the forecast. So it takes a couple more days for, let's say, 1,000-acre lake to break up than it does a 100-acre lake. So there's a lot of reasons for that. The other thing that happens in Minnesota, because we're a tall state, I say we're a tall state, is that latitude can cause very low sun angle in the north and higher sun angle in the south. We actually cover almost 3 degrees of latitude, but we cover about 400 miles or 600 kilometers from the bottom, from the Iowa border basically up to the top of Minnesota. And that changes what the sun does because it can be more direct in the south than it is in the north. And the other thing that makes a difference is deep snow cover. And the more snow cover you have, the slower ice out occurs. So, and then there's some other things too. Wind, super windy days will tend to put a lot of energy into the ice and break it up quicker. Rain carries a lot of heat and also will start to make the ice soggier, and streams and runoff. Lakes that have really big streams or rivers flowing into them break up really fast. And I noticed the Snake, that looks like a lake when you cross it on Highway 35, was breaking up earlier than many of the water bodies around. So lots of things change. Lots of things will influence when the ice goes out. So let's look under the hood, and again, this is what my friend Jane Reed would call the geeky bits. But the models that we run at Minnesota Sea Grant are day by day multiple regressions that forecast ice out day for all Minnesota lakes. And these are the kinds of models that are integrated into that ice out clock. Be thankful you don't have to think about that very much. We've done that for you. So basically every day has its own predictive equation. And as we get the new weather data, we can update the clock and give an updated forecast, excuse me, of ice out. The variables that are used in the lake ice out clock are those that I showed you, the freezing degree days and thawing degree days. And it's the amount of freezing weather and the amount of thawing weather received so far during this year, this winter, basically. And we consider freezing from October 1st, all the freezing days from October 1st, and thaw since January 1st. And these models, because they don't include explicitly snow and latitude, require just a little bit of a handicap for snow and latitude. We do have models that include those too, but they are pretty complicated to integrate into the clock on the web. And so we are developing those more accurate models and hope to integrate them into the clock in the future. And I guess I've already told you all this, but here's a picture of my wife behind a big pile of snow last year. And on the bottom, you can see why the sun's angle might have some difference. It has to pass through a lot more atmosphere and loses some radiant heating ability as it goes to higher latitudes. So I told you that already. I seem to be getting ahead of myself. We did this historical analysis of 5 kinds of data to make these forecasts. More freezing weather from fall to spring makes thicker, colder ice. So we looked at freezing weather. Wow, more thawing weather. Of course, it takes temperatures above freezing to melt ice, right? That's rocket science. Snow cover is also important. Heavy snow cover insulates the ice on lakes, and the white color reflects the sun's energies. And we also considered bigger the size of lakes. We, thanks to the DNR, have a database of all Minnesota lakes, all 14,372 of them, I think, or maybe I missed by a few. And we also look at how far north the lakes are. And that helps improve those predictions. We analyzed thousands of lake ice out dates from the Minnesota DNR's wonderful website. We also use the DNR lake latitude and size data and weather data from the National Weather Service, and looked at data back to 1963 and 1964. A couple of lakes actually have data going back into the late 1800s on ice out, which is remarkable. And I can hardly wait to actually graph those out and see where they are. Osakis, for example, has really unbelievable records, and several other of our lakes. But we analyzed more than 14,000 ice out dates. So this is what last year looked like. On the left, you see snow depth, and it's blue and purple because that's the color I turned shoveling snow, I think, last year in Duluth with our 10 feet of snow. And at this time last year, actually a little bit later, about a week later, we were looking at a forecast of below freezing temperatures. Here's where we are now. Brown is for the mud season. I have friends who are living about at this latitude who say, yeah, we lost winter, but we got a wonderful 2 month mud season, which we see on our carpets from when the dog comes in and other ways. So it looks brown. It's a mud season. On the right-hand side, this is the 3 to 4 week temperature outlook pulled in from this morning. We're looking at above average temperatures over the next about 3 to 4 weeks. So really different seasons. Um, and now here comes the caveat part where I say predicting the future is hard. There's always uncertainty. In fact, weather makes all the difference, right? Whatever happens between now and ice out really matters. But we're using some methods that might give us some help with that. We're going to concentrate on the north central Minnesota lakes because, well, they still have ice, a lot of them. And I'm going to talk about mostly 1,000 acre lakes, a standard 1,000 acre lake. That if you're thinking about a bigger lake, and I'm thinking here about your ice out pole, for example. If your lake that you have to make a forecast on is bigger, you can add 2 or 3 days for every tenfold increase above 1,000 acres. And the ice out clock right now is suggesting for, around Brainerd, Hibbing, Park Rapids area, that ice out will happen between about the 25th of March to the 10th of April. The western and southern lakes, and I'll show you a map of some of the ice out forecasts in just a second here. Western and southern lakes are going to lose ice quicker. Lakes near the Lake Superior coast go out more quickly. The temperature there is moderated, of course, by the now wide open Lake Superior that only got about 2% ice this winter, one of the lowest rates of ice in history. The statistics include latitude and snow give us a forecast of just about the same thing, about the 25th of March to about the 11th of April. You may need to handicap a little handicap of taking off a week due to lack of snow and forecast warm weather. But even considering snow, we're probably most of these lakes at the end of March to the early part of April. And everything, as I said, depends on weather. For the Hibbing Airport region in 2023, we forecast May 6th to May 8th, plus or minus 5 days, and hit it pretty close for a lot of the lakes. And now we're basically saying for this region, something like April 1st to 11th, plus or minus some days because of the extremely low snow cover. I'm going to try to wrap it up pretty quickly. So I'd love to answer questions. So please don't forget to put questions into the Q&A. Anything you'd like to know about that I can tell you something about, I'd be really delighted to tell you about. Okay, here's what the Minnesota Sea Grant ice out clock looks like. And I see I put a note to myself that here's a note to John, put the ice out clock and link in the follow-up emails, and that's where it is. And it reminds me to tell you that you will get this link after the webinar is over. But what you're going to want to do is watch the clock for your region. And the reason we base these on airports is that's where the best weather data are. And we can really count on those data because they're certified by the National Weather Service. It'd be great if we had a bigger network because there are a lot of little local climates that make a difference to our ability to forecast these things. But go in there if you're in the ice out clock, go and highlight your closest airport, and then click on the Get Data button down in the blue thing down at the bottom of the map, and then it will automatically give you a central middle forecast there's error on it, of course, there's variation around it, but it'll give you that forecast for 100 and 1,000 and 10,000 acre lakes so that you can get some sense of the range. And as you see, if you can see that, it's kind of tiny. 100 acre lake is looking like for Hibbing, I think this was this morning or late last night, the 9th of April going up to the 11th for 1,000 acre lake and maybe the 14th for a really big lake. But as I say, things depend on weather. Here's what the models are forecasting today, and before this is the big multivariate model. It's a little bit more complex than the one that's in the ice out clock, but they give really similar numbers. And I think you can see that. And I think one really important thing for us, if you're in the northern half of the state, to realize is that we are really special in that we have some of the later ice out than across the entire region. And this is because we're kind of protected from coastal influences and also some of the weather influences coming from the west and the south. So, but what you'll see is International Falls is looking like somewhere around April 14, and this is for a 1,000-acre lake. And you need to handicap these a little bit, probably. April 1st for those up near Grand Marais, Hibbing, April 11th-ish, March 29, closer to the coast over in Duluth. At Park Rapids, something like April 2nd. Grand Forks, chilly place, and so far not that much thawing weather. And so a little bit later, Fargo, quite a lot earlier, uh, again driven by weather. And then you can see that in the center of the state, the lakes are, in basically ice out is imminent, and heading down into the southern part of the state, of course, ice is already out in most cases. Now you may say, well, John, it's really easy to forecast something that's already happened, but we were actually forecasting these similar early dates um, uh, several weeks ago. Everything depends on weather, as I said, and that's the third time. Shallow lakes and those with big watersheds or large stream inputs will be faster, and high winds can accelerate all this. But this can at least give you a central guide um, to um, what ice out looks like. Now, some complaints. Here's some things you can do to help make future forecasts better. Um, the National Weather Service has a snow depth reporting system, and snow depth is super important because it insulates and reflects. And you can join the Weather Observer program. I would say the weakest part in our analysis is being able to count on snow depth measurements. And the other thing is, if you're a hobbyist like I am and others of us on this call are, I know, you could connect your weather station to the National Weather Service system and give them temperature readings. The temperature readings that the thaw and freeze degree days are just based on average daily weather, and it'd be really nice to have even more precise data. And if you are watching or have records of ice up and ice out, the Minnesota DNR has a terrific site that you can get to um, and actually connect your data really easily via Facebook and other means to improve our ability to understand and predict ice out. So with that, I think that's enough to talk about, but I sure would love to have questions. I'd be happy to answer anything you'd like to ask, and I'll say I don't know, or we'll find out if I don't know, or I possibly can find out. Hillary Sorensen of Minnesota Sea Grant is actually going to ask the questions, and Jan and Carrie from Itasca Waters are going to help in background moderating the question and answer session. And they'll combine similar questions, and we may not be able to get to all of them. But if we don't get to your question or you have other ones later, please send me an email. It's really easy. It's my last name at umn.edu, and I would be so happy to answer any questions you've got. So, and I'll stop sharing now, and I can reshare later if there's something you want to see again, and maybe ask Hillary to turn on her video, and she can grill me. You have anything? Does anyone want to know anything, Hillary?
They do. We've got some questions. We've got a lot of good questions.
God, I hope I have some answers. Okay, well,
We've got a lot of good questions. I
good.
also do want to plug the community collaborative rain, hail, and snow monitoring that
Yeah.
John mentioned earlier. It's a lot of fun. I used to do it, and it's a lot of fun to track rain and snow and things in your on your property.
Well, and Hillary, I'm glad you mentioned that because that was one of the most frustrating parts of the analysis because we know, especially this year, having no snow is a huge deal. Um, and probably a lot of you have noticed that. Um, and but our snow records, despite the really, great actions of the National Weather Service and others, are some of the have the most missing values, really. So it makes the analysis harder and less accurate. But love to, yeah, snow is a deal.
Okay, so we've got several questions. Hope we can get through all of these. This first one from Paul, I love this question. It's not a plant, it's a great question. What is the universal definition of ice out? I have read that it is when a boat can safely navigate from one end to the other, from one end of the lake to the other, though this seems to introduce some subjectivity.
Yeah, thanks, Paul. It was Paul, yeah. And
Yes. Mhm.
um, it comes so fast that it's almost, I mean, because of the physics that I mentioned, having so much uh, well, 40 degrees is not really toasty, but I mean, there's a lot of heat in water, and it can melt it out really quickly. It rarely, and sometimes in the records, you'll see several ice out dates for the same lake in the same year because different observers saw it slightly differently. But um, it usually is that you no longer have, well, you have open water in the center and no longer have ice protruding from the shore. I can't say it's a universal definition, but I would say almost anything is as good as almost anything, because it happens really quickly mostly. Now I know in Pokegama in Itasca County, some arms of that lake will be ice free at other time, at different times, and that has a lot to do with the size and the fetch the wind can blow across it and a variety of things. But it usually doesn't introduce a lot of variation. And I don't think there's a really universal definition. Now, if you talk about ice up, when the lake actually gets ice on it, that's tricky because it's really hard to say when you have actual ice. You can have a whole slushy layer that looks like ice. You can have extremely thin ice that's ephemeral and so on. So that's why I'm not building an ice up clock because it would also be dangerous for people. But yeah, thanks a lot for that. I appreciate it.
All right. Thank you, Paul. Next question. Do you use satellite imagery in determining ice out on lakes?
No, we use people's eyes who are living on lakes, and that's what that DNR database is built from is observations of actual people who have been on lakes, and oftentimes it is Minnesota DNR or Pollution Control Agency observers who will just simply say, "Okay, ice is out here." Satellite imagery would be great. Um, the because there's a lot of cloud cover at various times of the year, particularly when you've got a lot of melting going on, it's a little bit harder to get a complete record. But yeah, satellites are wonderful for a lot of things.
Thank you. Okay, this one from Victoria, George, and Mark. Can you talk more about what early ice out will mean for algae bloom, diatoms, fish population, spawning, and plants?
Well, there's a big question. I could say yes,
No
I
pressure.
can. I can, a little bit. And again, I'd say we're kind of in uncharted territory here because we haven't, we have cool water systems or cool and cold water systems that are now seeing um, longer growing seasons. So I would say, from the standpoint of aquatic plants, uh, you might see greater growth because there's a longer growing season. You might also see those plants die a little bit earlier as they get warmer and float up and stuff. Um, I think we can expect, depending on water clarity, there's an interaction there too, but I think we can expect, more algae growing on rocks and logs and stuff the longer the season persists. Now, fish is a really interesting question, and Don Schreiner of Minnesota Sea Grant and I have talked about it at some length, and I talked with the Sea Grant director this weekend, last weekend, about the same kind of issue. And the answer is sort of, it depends. Even my grandson asked me about this one. And the prevailing wisdom is, um, if we get persistent long seasons, we'll get warmer water and we may end up getting different fish assemblages. May. And spawning is another question that we need to be thinking about and studying. How are local species going to react if they have persistent early ice out? Don Schreiner says these things are really, they're really flexible and resilient. But on the other hand, Thomas Hook of Purdue University just told me a couple days ago, the other issue you have to think about is when the little larvae hatch after spawn, do they have the right food? And what does that food do? Is there the right zooplankton there? So there are a lot of big questions in your question. And I think, well, I could be safe to say that if we have persistent early ice out and longer growing seasons, we will see changes in our water bodies. And we're at Minnesota Sea Grant and other places, we're trying to figure out where those things are going.
Yes, I've heard the big question before about how it might affect walleye spawning.
Well, there's a group of DNR fisheries people who wrote a really interesting paper that I could link you guys to if you want, that talks about fisheries management with changing temperature in lakes. And the senses are eventually fisheries managers will not manage for walleye and say trout in streams if the temperatures are consistently higher. They'll manage for warmer water species because those are the things that can succeed. So if anyone's interested in that, I can link you to the article. It's one of those kind of heavy duty scientific things, but Itasca Waters was thinking of having a webinar on that topic. And if you're interested in that topic in particular, please do the post assessment after this and say so. And we'll be, the Itasca Waters group can take that under consideration for next year.
Wonderful. Thanks for that.
Mhm.
Okay, this one from Craig. The ice out clock that I can access on my phone does not have an adjustment for snow and latitude.
That's correct. That's correct. And it's because we couldn't do it fast enough, Craig. And also, it would require you to know what the latitude of the lake is. And our hope is we can build a better mousetrap in the future. But as a guide, I would say, if you're looking at a lake that's, you got to handicap it just a little bit because we couldn't build all that in very well. And also our snow data, we have great analyses with snow data and latitude, but trying to harness those for you regionally is difficult, but it's not something we're going to quit on. But I would say for latitude, I think there's some instruction in the little fine print just above the map. It should give you some guidance on that, and you're going to have to adjust the forecast a little bit so far. And the major things that drive it are, in fact, thaw degree days and freezing degree days and lake size, but there is also an effect of snow and latitude, as you point out.
Wonderful. Thank you. Okay, this question from Brianna. Thanks for this webinar. Very informative. Is the acreage for each lake based on the individual water body or the watershed?
Brianna, it's only the water body itself. It's kind of that part of the lake that will receive direct solar radiation and receive water. But a big watershed, if you have a really big watershed with a lot of melt in it, of course, it's going to really speed up the ice out. And you've probably seen that on some lakes. Any lake that's sort of a riverine kind of lake with a river coming in one end and going out the other is going to break up really quickly. and more quickly than those that are not receiving so much water. Yeah, so yeah, it matters.
Okay, thank you. Here's another one that's probably its own webinar topic. How do changing climate and weather patterns impact ice-off predictions?
Yeah, thanks. I was wondering to what degree La Nina and El Nino effect may have some kind of predictive power for our ice out. I I can't find any pattern and so far, and I tried because I thought, well, that'd be really handy because climatologists can tell us when one or the other of those, the North Pacific gyre is doing this or that, and it does have an effect on our weather, and that is for sure. But there really isn't any consistent driver. I thought I would see, you know, El Nino years and La Nina years having really different ice out, but they don't seem to. I think what matters more is how those large scale climate, and I'm no climatologist, and yeah, if there's a climatologist in the on the bus, please cry out but um yeah, it's how those bigger weather patterns really influence our local weather that seems to matter, as far as I can tell from the data we've got. But thanks for that. I like the big picture, and it's important to think on that kind of scale. Thank you.
That echoes what I've heard some of our state climatologists say before, that these large weather patterns, on average, make it just a lot harder to predict these climate forecast, quarterly climate outlooks, just makes it a lot harder.
Yeah, I sometimes say, well, I'm really glad I don't have to predict the weather or forecast the weather. They do a terrific job, National Weather Service and others, and it's really hard to do. But then again, I make forecasts that go out 2 months or so. But this is based on, you know, thousands of observations over time in Minnesota. But and as I said before, the weather between now and ice out makes a huge difference. If all of a sudden it warms up really a lot, then it's going to come earlier. If it cools off and we keep getting freezing nights and this ratcheting effect of freezing and cooling and freezing and cooling, the northern lakes will take longer. So, yeah.
All right, thank you for that. What role does wind play in how it affects melting ice?
There are a couple of roles, I think, and again, we're getting into climatology, which are, and sort of some physics that is really not my strength, but from a limnological or lake scientist kind of point of view, wind, a warm wind is going to probably do more work for melting, than a cold, than warm temperature and calm winds, and that has, I think, to do with stuff I don't understand, having to do with how much heat transfer you can get locally and so on. Um, but wind does another thing, and that is it tries to move the ice, and um, and and that will um, assist in its breakup. And I think some of you have probably observed that when the ice is cracking and you have high winds, you can have massive shore damage and infrastructure damage. And I've seen this on Mille Lacs really a lot. A couple of years ago on the eastern shore, it was just amazing. And you can get this ice push that goes way up and does a lot of damage. But what it's doing is it's also assisting a breakup of the ice. And so so what did I calculate? Like a 10-foot by 10-foot piece of ice being blown by a 30-mile-an-hour wind is generating the same force as a skid steer. I mean, it's a lot because it's heavy and it's moving even slowly. Yeah, wind is important too, but the wind records are harder to get at, and I'm sure it has some effect, but we're accounting for a large amount of the variation and breakup, and maybe we can integrate wind into the future sometime.
Okay, thank you. Okay, I have a few more questions I'd really like to get through before the end.
Okay,
So
okay,
here we
okay.
go.
We have
Okay,
4 minutes. Yeah, right?
four
Before we have to
minutes.
let people go.
If it snows heavily, this one from Ellen, if it snows heavily before the lake freezes, does it affect how and when the lake freezes?
Um, what if it snows heavily on an open lake, it's going to cool the surface. Um, now, um, it kind of depends on what the temperature of the lake is because water does a really interesting thing in that it's heaviest per volume at about 40 degrees Fahrenheit. So I hate to give you an it depends answer, but it kind of depends on what the surface of the lake is. But what really freezes the lake isn't the snow that sits there and then freezes up. It's the formation of ice crystals called frazzle ice, and then they bond together and make this layer of ice. I have a whole story on that on the Minnesota Sea Grant site if you want to read it. It's not terribly long. I think it's about a 10-minute read if you want to go look at it. It talks a lot about how ice forms, but I can't really say, kind of depends on the circumstances, and I hate answers like that. Sorry.
We can include a link to where we can find that story with the email that comes out after as well.
Yes.
Okay. Is there this one from Brianna? Is there a full report with the inputs and how the model was built that would allow others to replicate this ice out clock in other states?
Not yet. We're working on it. We got the model built for the people first, and then we'll put it together for the scientists. And they'll want a whole lot of other T's crossed and I's dotted, but and we'll be working on that soon. We got a few other odds and ends to do, but frankly, if you could drive it with weather data, since it includes latitude, if you can drive it with local weather data, I would guess the models will work pretty well. It's not one model, but many, and you will get that into a peer-reviewed type scientific publication as soon as we can.
Wonderful.
If,
Okay,
if,
thank
if-
you.
get in touch with me if you have something specific. In fact, I would love to apply this and similar models across right across the northern tier of the U.S. I think it could work.
Thanks, John.
Mhm.
Okay, for lakes with many bays, where does the official ice out date get taken? Shallow bay or deepest, something in between? Is there a rule about this?
No, there's no rule. But usually it's pretty obvious. But sometimes if it happens at different dates in different parts of the lake, they usually are recorded in the DNR's database. And Papegama is an example of that, and there are several others. I think Leech Lake also, the um, Walker, the High Banks Walker area probably is quite different from the Big Lake and so on. Um, but those you can look up those data actually, ice out data for different parts of bigger lakes on the DNR's website, and I guess that is linked, I think, um, in a couple of places, like in the little site that describes this seminar, I believe. But if not, I'll get it into the post, the follow-up letter.
All right, thank you. Well, we didn't quite make it through all the questions. I apologize, but we are at 1 p.m. and please do feel free to follow up with John with any questions that were not able to be answered yet. So I'll pass it back to you, John.
And
Thanks.
I would say thank you very much for being interested. And I echo what Hillary said. If there's more you want to know, it's our job to help you with it. So give us a shout. Happy to hear from you. Downing@umn.edu, very easy. Or you can just go to seagrant.umn.edu and you can find us all. So thank you very much for being with us today. I appreciate it. And keep off the ice, for heaven's sake. I mean, if there is some, it is really fragile. So be careful, please.
Thank you.
Thanks.